So domain and range, really important, and we're starting today with a graphical understanding of domain and range. Does anyone remember anything about domain? It's been a long couple of years. Yeah. Domain is our independent variable. Domain is the independent variable, and our independent variable typically is the x variable, or all of your input values. All these things are different words for domain. So domain is, I like to think of graphically, our x values or our x-axis, okay? So if domain is the x values, what's the range? Yeah, the range are all of the y values or our outputs. And it is the dependent variable because it turns out that whatever we plug in for x is going to give us that y value. So that y value depends on what we plug in for x, okay? So that's why it's called the dependent variable, because it depends on what we plug in for x, okay? So this is what I really like to talk about today for domain and range. Domain is the x values or the x-axis, and range is the y values. And you'll notice that those are alphabetical. D before R, alphabetical. X before Y, alphabetical, okay? So keep that in mind. Let's look at example 1. Example 1, use interval notation. Use interval notation to describe the domain and range. Use interval notation to describe the domain and range of the function. Make sure you're writing example 1 and those directions. Interval notation. Use interval notation to describe the domain and range. Use interval notation to describe the domain and range. So this looks like a complicated graph. You do want a small sketch of this graph. And here are some things that you should make note of on your graph. It doesn't have to be this glorious. But first of all, we have this solid dot here at -10, 3. So that's important, -10, 3. And it goes up a little bit, and it gets as high as 4. So if you want the ordered pair, that's -7, 4. And then it goes back down, and it reaches this sort of lowish point here at 6, -1. And then it ends here with a big solid dot at 9 on the x-axis, 0 for y. Okay. So make a little sketch. I drew those numbers kind of small. This is -10, 3, 7, 4, 6, -1, and 9, 0. So make a little sketch of your graph. And again, you can make just a little sketch of this graph too, and we can label some points later. So that would be good. We want to find the domain, excuse me, domain and range. And we're going to use interval notation, which I'll talk about in just a second. All right, we're going to find the domain and range. Tell me what domain is. X values, or in our case, the x-axis. And so when I talk about domain graphically, the easiest thing to think about is, and I'm going to write this in a bubble, how far left, comma, right, how far left and right does the graph go? Is the graph. How far left and right is the graph? Because our x-axis moves left and right. It is our horizontal axis, all right? And so when we ask what's the domain, we want to know how far to the left does our graph go and how far to the right does our graph go. So when you look at this graph, how far to the left does it go? -10, right here, -10. That's as far as the graph goes. It starts at the left side at -10. And then how far to the right does it go? 9, absolutely. It stops right here at 9. That was easy, right? And at -10, we have a nice solid dot, a nice included point here, an absolutely included point. And if we have an included point, then we're going to use a bracket. And this bracket has a little equal sign built in that tells us we're allowed to equal that point, okay? What about at 9? Do we have an included or an excluded point? Included point. C-L-U-D-E-D. It's an included point, nice solid dot, so we use a bracket to include the value of 9. All right. If the domain asks how far does the graph go from the left to the right, what do you think range asks? How high and how low? And we're going to do that in order from low to high. So how low, comma, high does the graph go? Because, again, range refers to the y-axis, and our y-axis is vertical. So we can have low values and we can have high values. So now when we look at this graph that they've given us here, we want to ask, how low does the graph go? What's our lowest y value? -1. Right here, our lowest y value is -1. So we're going to start with the low value. And then we say, how high does our graph go? What's our highest y value? 4. Right here, that's as high as our graph goes. We don't have any higher points than 4 on the y-axis. So range refers to the y-axis, the y values, and we go low to high. And sometimes I write that underneath. Low to high, left to right. Now, at -1, should we have a bracket? So at -1, we have just this line, right, that's passing through. But what creates these curves, these lines? Thousands and billions and trillions of ordered pairs, all collections of all these ordered pair solutions. So is there a point there? There is. That's what makes up the lines. All these ordered pairs, these ordered pair right there, and there's an ordered pair right next to that one, and there's an ordered pair right next to that one. That makes up the solutions to this curve. And all of those ordered pairs put together, they're mashed so closely together that they create the line. Okay, so there's a billion ordered pairs, a billion nice solid dots there. So it is an included point. What about the 4? Should we include it as well? Yes, because again, the line is a whole lot of ordered pairs, a whole lot of big dots. Okay, to be contrasted with this graph now, when we look at this graph, our graph goes up, so you should make a sketch, just a rough sketch of this graph, okay? And then we will add details as we go on. We want to know the domain. I'm just going to use a big D for domain and a big R for range. All right, domain refers to what? The x-axis. And that's going to be how far left and how far right the graph goes, because our x-axis goes from left to right. So, ladies and gentlemen, how far to the left does this curve go? What's our farthest left x value? -6-ish. -6, right there. That's as far left as we get. So let's write that down. And then how far to the right does our graph go? 10, 10-ish right there. So negative 6, comma 10 from left to right. Now the question is, what do you notice that this x value of negative 6, what's our graph got there? An open circle. Is that included? No, that means it's excluded. Excluded, not included. So we're not allowed to equal that point. I don't want to use brackets. Instead, we use parentheses anytime a point is excluded. We're not allowed to equal it. That means negative 6 is not an answer. But negative 5.9999999999999 is. Okay? Infinitely close to negative 6 on this right-hand side is a value that gives us an ordered pair, but negative 6 does not work. Okay? What about at 10? Should we use a bracket or parenthesis? A parenthesis again, because again, this point is excluded, not included. I ran out of room there. Okay, so when it's included, we use a bracket. When it's equal to, we use a bracket. When it's not equal to, we use parentheses. Okay, range asks, looking at the y-axis, how low and how high does the graph go? So look at this curve. What is our lowest y value? Negative 9, right there, negative 9. So you can add that detail to your graph. And then how high does it go? What's our highest y value? 5. Very good. Right here it tops out at 5. So this one is tricky. At negative 9, should we include that y value or exclude it? Exclude it. Again, at negative 9, we've got this open circle here, so we're going to use a parenthesis. It's still excluded. But what about at 5? Should we include or exclude the value of 5? Include. Yeah, it's a nice solid line. All right, it's a nice solid line. You can imagine that like a solid dot, so we want to include it. So we're going to use a bracket at 5. And this is interval notation. Does that make sense to you? Yeah? Okay, a solid line, solid dot means it's included. Okay, good, good, good. So one more here. Again, make a sort of something like this curve. Doesn't have to be beautiful. You don't have to write all the numbers. Make a little axis and a nice little roller coaster there. Solid dot on the left, open circle on the right. Make a little sketch. And again, we want the domain and the range. What does domain refer to? X-axis, X values. We want to know how far left and how far right the graph goes. So how far to the left does this graph go? Negative 11. So that's a detail you could put on your axis. Just write negative 11. Okay. Should we include or exclude negative 11? Include. Very good. Include means bracket. All right. And how far to the right does our graph go? Positive 11 right over here. So should we include or exclude 11? Exclude, which means parenthesis. Of course, the other way. All right. Very good. Range refers to what? The y-axis, meaning our y-axis that goes from low to high. Low to high. So when we look at our y-axis, what's our lowest y value? Negative 11, right here, negative 11. That is our lowest y value. Up here we have a negative 7. This is lower. So negative 11, should we include or exclude negative 11? Include. Very good. We got a nice solid dot there, so that makes sense. And then how high does our graph go? 5. So that's something you could put 5 on the y-axis. And should we include or exclude 5? Exclude, because again, that point over here is excluded. All right, any questions on domain range graphically? Okay, I hope all the problems look like this. Sometimes they like to surprise me. All right, example 2, determine if the following is a function. Example 2, determine if the following is a function. A function is a very special word. To be a function, to be a function has a very complicated definition that I just hate. I hate the definition of what is or is not a function. And so I always abide by when in doubt, graph it out. So I'm going to write that down. When in doubt, graph it out. We can make sketches of things like these ordered pairs because knowing if something is a function by looking at a graph is super easy. Does anyone remember what the test is for if it's a function? There's a special test. Emma?
Is it the vertical test?
Vertical line test is exactly right. So when we want to answer the question, is it a function? All we need to do is ask ourselves, does it pass the vertical line test? All right, does it pass the vertical line test is the question we need to ask ourselves. So looking at this graph here, again, make a little sketch. It doesn't have to be beautiful, but just make a little sketch of this craziness here going on. And in order to know if it's a function, all I have to do is draw a vertical line somewhere. If I draw a vertical line on this particular curve, I see that it intersects my curve in 2 places. That is not allowed. This fails the vertical line test. Now, I could be strategic and say, what if I draw a vertical line right here? Then it would only intersect in one place. That's okay. But because it fails somewhere else, it fails the vertical line test, and this means it is not a function. So to pass the vertical line test, it can only hit once everywhere on the graph. It can only intersect your curve one time. All right, so if it intersects your curve one time, if your vertical line intersects your curve one time, it passes the vertical line test. So let's see what happens here. I don't have a graph. So I'm going to abide by when in doubt, graph it out. So I'm going to make a wee sketch. 1, 2, 3, 4, 5, 6. And it looks like I need to go to -8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Okay. So I'm going to make a wee sketch of these ordered pairs and see what my graph looks like. +1 down 8 is right here. -6, -4. 1, 2, 3, 4, 5, -6. -1, 2, 3, 4. Right about there. 3, 7. 1, 2, 3 to the right. 7 up. 7 up. And then -6, 1. 1, 2, 3, 4, 5, -6. -6 up 1. There we go. So I have plotted these ordered pairs, and what do you notice about these ordered pairs? What happens if I try to draw a vertical line? Yeah, right here. Whoop, they're stacked up. That is a fails vertical line test because we have 2 points that are stacked on top of one another. Okay, that fails the vertical line test. Here I can draw a vertical line, it's fine. Here I can draw a vertical line, that's fine, but this fails. That means this is not a function. So vertical line test is the test, and it's super easy if you've got a picture. Takes a little bit more time if you're given ordered pairs. You just need to check to make sure that they're not stacked on top of one another. Okay, questions on that? All right. All right. Wait. Okay. It's a long day. Sorry about that. Example 3, evaluate the function. The nice thing here is we're doing some just notation, evaluate the function. And the nice thing is if you have a calculator, you can totally use your calculator to help you out. And that's going to make life a lot easier in most cases. Evaluate the function. So we have f of x equals 4x squared plus 6x minus 2. And we want to find f of 5. So right here is what we call function notation. Function notation. This is read f of x. All right, that's how we read that. And function notation is used all the time in higher math because it gives us a little bit more information than just a plain old generic x and y. Okay? Function notation actually means the same as a y value, so this f of x really is just fancy notation, fancy for a y value. But it's really, really easy for us to use. We want to find f of negative 5, and so I'm going to write that down, f of negative 5. And what I want you to notice is that they've placed a number, they've placed negative 5 in place of where there originally was an x. So it is cluing you in and saying, hey, I want you to go to your f function and I want you to replace the x that you see with what value? Negative 5, exactly. So we're going to go to our little function rule here, and everywhere you see an x, we're going to pop in negative 5, and that's exactly what it wants you to do. Plug in everywhere you see an x, everywhere you have an x, we are popping in a negative 5. And this is where you go to your calculator, because you can, and I encourage you to. And you go to your calculator, and because you're very careful when you plug stuff in, and when you plug stuff in, you use parentheses. If you use parentheses, you'll always get this correct. Plus 6 times negative 5 minus 2. Your calculator can do all the math for you. This is the work I would want to see on a test. All right? And so we can plug it into our calculator and say, hey, 68, super. F of negative 5 equals 68. This is done. This is our solution. And what it tells us is that we have an input value. We plugged in a negative 5, and it spat out a 68. Function notation is awesome because if we have an input-output, then that's actually an ordered pair on our graph of our f function. And that's very cool. It gives us more information. All right, if we had just said plug in an x and it says y equals 68, it's not as clear that we have an input-output ordered pair, an x value and a y value, okay? So we use this a lot to help us graph, and you'll see that tomorrow, I think. We'll be doing that with graphing. So let's try one more. F of x equals negative x squared plus 6. And they want us to find f of negative 3. What does that tell us to do? plug in -3 because it is literally taking the place of, it's taking up the space that x was, all right? So it wants us to replace our x, everywhere we have an x, we replace it with a -3. Now this negative is out in front, so we leave it out in front. And in place of the x, I'm plugging in a -3. Lots of negatives there, be careful. I only fill in the x, which means this negative is still out in front. Can I multiply negative times negative and make it positive? We cannot. Why not? You got to do the exponent first, okay? So don't try to clean things up too early. Again, I'm going to say let's use our calculator because we can. That's what they're for. I have a negative out in front and then parentheses -3 squared plus 6. And we get -3. All right, this is our output of -3. And we're done. Questions on that? What is -3 quantity squared? What does it mean? Kaylee. Yeah, it means whatever is inside the parentheses, we multiply it 2 times. So -3 times -3. That gives us +9. What is -3 squared? -9. So what is the 2 affecting? Just the 3. It has nothing to do with the negative. Here the 2 is affecting everything in parentheses. But down here, this is saying there's a negative out in front, and we need to repeat the 3 2 times. So this is a very, very different answer. This is the #1 algebra mistake students make, okay? Don't be the kid who makes this mistake. Super important. And using parentheses and a calculator can be very, very helpful, but if you do the parentheses wrong, your calculator is not going to help, okay? So be very careful. All right, got some more stuff here? I know, there's a lot today. So this is using function notation. This is going to be very quick on your Delta Math today. Given f of x equals y, so this is function notation. And again, it's really just saying we have an x and a y value. We have an ordered pair. So we want to evaluate these values given this graph. Given f of x equals y, and that's this function here, this little graph. And I'm going to give you these ordered pairs here. Point B is at the ordered pair -6, 7. Point A is the ordered pair 4, 3. C is the ordered pair 2, -5. And D is the ordered pair 3, -6. So we have this using function notation here. Okay, here they have evaluate f of 3. And you'll notice the 3 is in place of what? It's in place of the x, so they're telling us that the x is 3. And so to evaluate it, we really want to know, hey, what's the y? Because f of x is supposed to equal the y value. So f at 3. So let's look at our graph and go to where x is 3. And what's our output? What point has an output when x is -3? Or sorry, when x is 3, not -3. D, yeah, that's point D. And what's its output? -6. So all it's asking for is, hey, what's your ordered pair? 3, -6. That's our ordered pair. Pretty easy. All right, f of 4. Which point has an x value of 4? A, point A. So what's its output? 3. Very good. Input of 4, output of 3. All right. C is a little different. What information are they telling us for letter C here? They're telling us the y value is 7. So what do they want to know? What's the x value? All right, so what x value gives us a y value of 7? Negative 6. There it is. There's our y value of 7. And that would be when x is negative 6. All right, letter D, f of x equals negative 5. Again, what are they giving us? The y value is negative 5, and they want to know, hey, what's the input value? 2. Very good. X equals 2. That was our ordered pair. F of 2, f of 2 equals negative 5, and that was that point C there. Okay, so it's really just giving us an input and an output. Very cool, very easy. Any questions on that one? No? Makes sense to you? Yep, okay. And on the Delta Math, they just ask what's the point, A, B, C, or D, which is pretty cool, pretty easy. I'm sorry, today is long. Okay. All right, last thing. This is it. And I don't think you need to write all these words, but example 5, evaluate. This is probably the hardest thing. Example 5, evaluate. Man, I'm already hungry. What time is it? 9:30? Good Lord. Okay. All right, given the function, here's our function. This is definitely something you should write down. I'm not going to use that. Here we go. F of x equals negative 1 plus 5x. What is negative 3 f of x as a simplified polynomial? This is what we're trying to figure out. What is negative 3 f of x? That's what we're trying to figure out, which is kind of weird. So these are probably the only two things you need to write down here. So let's talk about what this means. This says negative 3. There's nothing in between here. That's obvious. What operation is between the negative 3 and the f of x? Multiplication. When there's nothing written, it means there must be multiplication in between. So this is saying negative 3 times this entire function. Well, what is f of x the same as? It's the same as all of that stuff. Negative 1 plus 5x. I am substituting in place of f of x. We are substituting the entire rule for f of x. Okay? And what do you suppose we need to do? Distribute. Exactly. We're going to distribute. Negative 3 times negative 1 is 3. And then negative 3 times positive 5x. Negative 15x. Done. That's it. All we're doing is substituting and doing the operation. That's it. That's function notation. All right, given the function, letter B, f of x equals negative x plus 2. Write that down. That's important. We want to be able to figure out what is f of x plus 3. That's the question. What is f of x plus 3? What can we do? So instead of f of x, what can we use instead of f of x? Negative x plus 2. That's what it's equal to. F of x equals negative x plus 2. So we can replace f of x. And then it says add 3. So what can we do? Negative x, 2 plus 3 is 5. That's it. Done. Weird, right? It's just operations with function notation. And the last one is the hardest. Given the function f of x equals negative x squared minus 2x, we want to know what is f of the opposite of x. What's this one telling you to do? Casey.
To multiply by another one. Or, no, make that x.
So this is literally, this is what we were doing before except without numbers. We're doing it algebraically. And this is what I would say is a challenge. So just like before, we aren't using x this time. They want us to replace x with negative x. So everywhere that you see an x, we want to replace that x with negative x. So instead of replacing it with a 4 or a 3 or a negative 2, we're replacing it just with negative x. So we have here a negative out in front. Instead of x, I'm going to pop in negative x. Then I have a subtract 2. And again, instead of the x, I'm going to use negative x. Can we use a calculator for this? We cannot because it has x's, not numbers. Okay, so this is when we have to clean up on our own. So let's talk about this. Here we have to do the exponent first. What is negative x quantity squared? What does it mean?
2x.
It means, if I were to write it out, I would write negative x times negative x squared. Negative times negative is positive, okay? And then x times x is x squared. So this negative x quantity squared simplifies and it just becomes an x squared. But there's still this negative hanging out in front. Here we can multiply negative 2 times negative x. What's that give you? Positive 2x. And this is our simplified answer. So being very careful, this is probably the weirdest thing. Okay. All right, ladies and gentlemen, do you have questions for me? All right, that was long notes. Go ahead and write practice 2.1 and get started on Delta Math. Thank you very much. Some of it's easy, some of it goes really fast.